Here we are graphing a quadratic. I know it's a quadratic because it's got an exponent of 2, which makes it a second degree function. So we are going, there's multiple ways to graph it, but we're going to make a table. We're going to plug in some numbers. I know that quadratics are symmetric, so we're going to plug in a good range of numbers so we can get the full shape. We're going to plug in -3, -2, -1, 0, 1, 2, and 3. And we're plugging them in for the x values. So if I plug in -3, I get positive 9 minus 3, which is 6. If I plug in -2, I get positive 4 minus 3, which is positive 1. If I plug in -1, I get positive 1 minus 3, which is -2. If I plug in 0, I get 0 minus 3, which is -3. If I plug in 1, I get 1 minus 3, which is -2. And I start to see that the values are going to repeat. So then I'm going to get positive 1 and positive 6. So then if I plot those on the xy axis, we've got -1, 2, 3 is at positive 1, 2, 3, 4, 5, 6. And then positive 3 will also be at 6 if we want to put in that point. -2 is at 1, and so is positive 2. -1 is at -2, but so is positive 1. And 0 is at -3. Connect this with a smooth curve. Should look like a U shape. And that is one way to graph a quadratic, which is using a table of values. The other way is to know that quadratics will start at 0, 0, but they might be shifted. So this has been shifted down 3 units, which makes the vertex at 0, -3. And then all quadratics follow a pattern of 1, 3, 5. It's kind of their slope, if you think of it that way. So that is going to be how you get from point to point. So we go over 1, up 1, over 1, up 3, over 1, up 5 to get those other points. You got to be careful of that. If there's ever a number in front of x squared, it multiplies your pattern and is going to make it either, it's going to stretch it or it's going to compress that parabola.